First, we'll begin discussing the inspection data. The objective of optimization is to create a data-driven program. So inspection data is really the foundation of your projects and programs. This is the inspection screen in BRM 523. You will need data for your decisions to be based on. So if you want detailed cost data and element deterioration, then you will need to use the element level inspection information. Element inspection data is when you rate the condition of each individual of your structure. And in BRM 523, that's 4 condition states for each of these elements. So for example, highlighted in blue, we have reinforced concrete deck, and you can see the amount of the total quantity that's in condition state 1, 2, 3, or 4. If you want to perform actions or work, like say beam end repairs, when more than 3 beam ends are in condition state 4, then you're going to need to define a beam end element as an agency defined element, so that you can later base decisions off that programmatically. You'll also notice that there's the validate button up here at the top next to the NBI scores. If you're not used to using the NBI scores, they are a general overview of the structure, the condition of its deck, its superstructure, and its substructure. The validate button, highlighted here in yellow, has been available since 522, but you can press this button to run an NBI submittal check on all of the information in this structure. And you'll also notice the Calculate NBI button, which will recommend what the NBI calculation should be on based on the NBI conversions, which we will be discussing in another video. Included in inspection data is also risk assessments. For many of you, this will probably be your first time seeing the risk assessment screen. Risks are expressed as a percentage, and it's arrived at by multiplying the likelihood of a hazard occurring and the consequences if the hazard does occur. Risk categories and properties can be edited, or you can define new risk categories aside from the default ones on the Admin Modeling Configuration Assessment page. We should also talk about work candidates. Work candidates are a way for you to define the work that needs to be performed on a structure. Different agencies actually use work candidates in different ways for their processes. Some agencies use work candidates as a way for the inspection teams to notify the planners of a bridge's needs. Others use them as a way for the planners to track requests from, say, lower districts or the local owners of structures. Some use work candidates so that the planners can show the inspectors what work is anticipated on the structure, and then inspectors can make recommendations based on that knowledge. Work candidates can also be used to hold historical information, like a work history of all the work that was performed on the structure, including the dates of when it was done and the costs and quantities that were performed. I know of one agency at least that syncs the work candidates to the maintenance crew task list, and then when that's closed out on the task list, a custom process marks the work as done here in BRM. On the analysis pages, there are tools to help you use work candidates to create projects, to roll them up together into projects. This focuses more on a bridge level analysis, so we'll only briefly discuss it here. The bridge analysis page also lets you compare the future effects of performing those work candidates. And it's also worth mentioning the needs list, which lets you filter down bridges in the same area, or maybe on the same route, which have similar work candidates or similar needs. For example, if you're putting together a paint program, then you can find all the bridges which have an identified paint need. So this should give you an idea of the inspection data and the work candidate data that you will need in order to base all of the optimization program from. The more detailed information you have, the better refined your optimization can be.